Thank you very much for the introduction. Maybe have first a word about rewilding and how it sort of compares to restoration. We always call rewilding sort of the gold standard for restoration because the aim is to make ecosystems functional again and to let animal populations thrive. You know, we have to sort of be aware that only 3% of the Earth's surface are still considered functional, if you exclude the deep sea, which starts 200 meters down. And that most animal populations are down by 70 to 90%. There are 3 times more biomass in chicken than in all wild birds that live on this planet. You know, so that's the kind of transformation that we have done. Rewilding, of course, only functions if you do it together with communities, especially indigenous communities who have an understanding of the land. And that only works if you find kind of an economy that sort of lives off the ecosystem. But you can use an ecosystem, you can live in an ecosystem without degrading or destroying it. And that's what sustainability really is about. Now, the challenge that led us to the journey that in the end brought us to the project that I am presenting was that we knew that everybody knows that climate change and the biodiversity crisis are essentially 2 sides of the same coin. But what exactly is it that connects them? And in practice, we always encountered that problem that climate, you talk about climate, everything is extremely data, very precise, and everything in conservation is sort of very vague and very fuzzy. So you get from the climate side always, okay, it's all right with the animals, but how many megatons? So the question for us was, is there any kind of a way, is there a link between the two where we can actually see the quantitative, the impact of biodiversity on climate? So that was actually the beginning of the journey, and the answer was actually right in front of us. And that is that climate science has been focusing on emission reduction, on technology, on CO2 storage by plants, and then lately also on the storage in soils, but it has totally ignored animals. The impact that animals have on their environment. And if you really see nature as a partner and not as something just to exploit, and you let nature do its way too, then you can increase the carbon sequestration by a factor of 1.5 to 10, just by letting animal populations thrive again. Just to give you one example, because the mechanism how that works is different from species to species and from ecosystem to ecosystem. Everybody knows that animal, it's a gnu, it's a wildebeest. There are about 1 million of them living in the Serengeti. What they do is they eat the grass, they defecate, stomp it into the ground, part of it goes up in the air, part of it goes into kind of a life cycle, beetles and whatsoever, but a part of it goes into the soil, it becomes soil carbon. Now, in the 60s, there was a rinderpest that came from Zimbabwe, and it sort of had a serious impact on the population. It went from 1 million down to 300,000. And the effect was that the grass wasn't eaten, it dried out, it burned, and the Serengeti became a carbon source. Now, you know, I mean, like there have been several different kinds of measures, both natural, both sort of activities undertaken, and the wildebeest population has recovered, and now it is again a carbon sink. And that means that these 1 million canoes, they manage to permanently sink into the soil 6 million tons CO2 per year, which is nearly the entire fossil fuel emissions of Tanzania and Kenya. I mean, that's serious. If you look at the dimensions, because you know, as you all know by now, we not only need to reduce CO2 emissions down to 0 by something like 2050, we also need to take the old carbon out of the atmosphere, 500 gigatons about. I mean, that's if we want to stay with the 1.5 degrees Celsius. 500 gigatons would mean from now on 6.5 gigatons CO2 per year. So if we take nature as a partner, there are 2 ways what we need to do. We need to protect the systems that are still working and functioning, and we need to improve the systems that are degraded. One system that's still functioning is the mesopelagic zone, by the way, that's below 200 meters. It takes every year 5 gigatons CO2 out of the atmosphere and stores it down thousands of meters below. If we start exploiting that and destroying that, we would have to add additional gigatons to already what we need to take out per year. Just compare that, the fossil fuel emissions from the European Union are about 2.6 gigatons CO2. Now, the huge opportunity in this is obvious, since the populations of most high potential species are reduced by 70 to 90%, there is an enormous opportunity. And that's where the project began. This is the Yale University. It might be familiar to some of you. It looks definitely like a place who needs reanimation also. And we're working with the Yale University on a model in order to sort of not have to do an extensive kind of a scientific study for each species and each ecosystem. If we find a model where we can just feed in specific data and then tells us, for an example, what's the return of my investment in terms of biodiversity and carbon, then we actually can sort of really provide important information for a lot of different kinds of persons. Also, it would be an answer to the question, if I had $1 billion, where would I get the most out of it if I invested it in getting biodiversity and carbon? So that's the project that we are running. In parallel, we are working on a global reference book that summarizes theory and the practice of animating the carbon cycle. There will be a number of scientific papers and articles coming out, and we are planning actually to have an outreach campaign to get this whole concept of animating the carbon cycle just into the kind of international debate. The results so far, we started in July 2022. It's actually a real fast-moving train. It's going to last till December 2023, the modeling, and with the Yale University. The global reference book, we got 50 top scientists. They are working on it already. They're contributing for free. Half of the funds are raised. We have increasing recognition by the conservation and the climate community, because that's one of the aims, that we bring those two communities together to work on joint action plans and have a joint idea of targets and aims. And our own network, which is, they are working on 130 million hectares, they have understood that that concept actually provides a massive kind of an argumentation for their work, it gives a justification for rewilding. The challenges that we face, new ideas need time to be accepted, amazingly long, The scientific model, we need funding, and the clock is ticking. This means we really do not have a lot of time. If you look at the EU timetable, for example, within 8 years, we want to take out 50% of the CO2. That's pretty tough. So our future vision is that the animating the carbon cycle is accepted and incorporated in global climate models and scenarios, that it also sort of becomes part of the biodiversity and treaty. So we are working on creating that link between the CPT and the UNFCCC. And then of course, once we've got the model, we can also calculate what the contribution of our own network would be. And then we also want to specifically focus on a couple of really, really bad things, and one of them is bottom trawling. So we need about 240,000. We have 240,000. We need another 240,000. Modeling at Yale is unfortunately expensive. It's one of the reasons why they are so rich. 500,000 we need about for this outreach campaign, because we don't have a lot of time, so this means we need to do it in a kind of a more massive way. Okay, there are a ton of KPIs, and I've just listed now the obvious ones, which is the modeling completed, modeling results accepted by the community, reference book published. But the main thing is actually that the model starts to get used and that it really adds value. This is, for an example, where I would say investors would also see a benefit in it, because in their due diligence research, if you have a model that is sophisticated enough to give you a good answer, if a certain investment really pays off in terms of carbon and biodiversity, then I think that would be certainly a very helpful tool. Yeah, the conclusion is, you can turn it around as you want it. If we do not see nature as a partner, we're not going to reach the 1.5 degrees. And there is one thing, technology is always part of it, but sometimes, you also have to do it without technology. And nature is the most natural solution and probably the cheapest solution if you just treat it as a partner. Yeah, and maybe a final word, and that is that we see the benefit of this project, for an example, not so much that somebody puts in money and gets money out. It's kind of like we heard before, it has a kind of a philanthropic nature to it. But we personally believe if somebody, for an example, comes in, puts the money on the table and gets an idea ownership of all of that, I mean, then this would be a super investment if you think about a good image, because that's going to be a game changer. Thank you very much.